back with another video of force and laws of motion. In this video, we are going to discuss about momentum. Let's get introduced to momentum, know how to calculate it, and understand some daily life examples. Who can ever forget this scene from the iconic movie Bahubali 2? We all have enjoyed watching this scene and we all even wished for the victory of Mahendra Bahubali. Now let's understand some physics involved in this case. Did you all observe that as soon as the soldiers hit the floor, they all got scattered away from one another? Why do you think, or what is the reason for the impact of the fall by the soldiers? Yes, of course, the velocity of the soldiers. The soldiers were moving with high velocity, and as they came and hit on the floor, they got scattered away from each other. Now let's look into another example. Here you can see that there is a glass window. Let's see what happens if a small plastic ball and a cricket ball is thrown onto the glass window. You observe that the plastic ball didn't create any impact, but as the cricket ball was thrown onto the window broke. What is the reason for the impact of the ball on the glass? Why did the cricket ball only broke the glass window? Yes, it is because cricket ball is quite heavier than the plastic ball. From these two observations, we can understand that there is an impact produced by any moving object which depends on the mass and velocity of the object. Newton introduced one such property called momentum. The momentum of an object is defined as the product of its mass and velocity. So, momentum is equal to mass into velocity. Momentum is represented using small letter p, hence the equation for momentum is p is equal to m into v. Now let's look into the SI unit of momentum. We know that the SI unit of mass is kilogram and the SI unit of velocity is meter per second. Hence, SI unit of momentum is kilogram meter per second. Momentum is a vector quantity. We know that velocity is speed with direction. Hence, momentum is having the direction of the velocity and hence it is a vector quantity. We can also define momentum as mass in motion. This means that objects which are at rest do not have any momentum. It is very clear because we know that if velocity is 0, then momentum is 0. Now let us see how momentum changes when mass and velocity changes. Since momentum is equal to mass into velocity, when the mass of an object increases, the momentum also increases. That means momentum of an object is directly proportional to its mass. So, heavier objects have more momentum than the lighter objects which are moving with same velocity. Momentum is also directly proportional to the velocity. When the velocity of an object increases, its momentum increases. Now let us consider two cars. These two cars have same mass, but one of them moves faster than the other. Then which car will have more momentum? Yes, you guessed it right. The car that has more velocity will have more momentum because momentum is directly proportional to velocity. Now suppose both the cars are moving with same velocity, but then one of them is heavier than the other. Then which car will have more momentum? Again you guessed it right. The heavier car will have more momentum than the lighter car because momentum is directly proportional to mass. When mass increases, momentum increases. This is the reason why trucks carrying heavy loads should slow down much before a traffic signal. Even with a small velocity, their heavier mass or higher mass can contribute to a higher momentum and then it will be difficult to stop at a sudden brake. Comparatively, smaller vehicles have less momentum and they can easily stop as and when they want. So now we have learned what is momentum. We have seen some examples also related to momentum. Let us learn how to calculate momentum. Here is a question for you. Find the momentum of a man of mass 75 kg who is walking with a velocity of 2 meter per second. So the values given here are mass and velocity. We know that the formula for momentum is m into v. So it's a direct substitution of the values 75 into 2. So on multiplying, you get the answer 150 kg meter per second. So it's easy to calculate momentum if you get the mass and velocity of the moving object. Now let's consider this situation. There is a car It's traveling with an initial velocity u meter per second and its mass is m. What will be the initial momentum of this car? Let us recall that momentum is the product of mass and velocity. Here the car is moving with an initial velocity u meter per second. So the initial momentum of the car will be mu. Suppose the car increased its speed and now its velocity is v meter per second. So then let's consider it as the final velocity. So what is the final momentum? Final momentum is m into v, that is mv. Do you think there is a change in the momentum of the car? Yes, there is a small change in the momentum of the car. Now how will you calculate this change? Subtract the initial momentum from the final momentum. That is, the change in momentum of this car is final momentum minus initial momentum, that is mv minus mu. So for any object which have a change in the velocity, we can find its change in momentum, or we can find the value of that change by this formula mv minus mu. Now let's apply this formula in a word problem. The velocity of an object of mass 3.2 kg increases from 2.5 meter per second to 9 meter per second. What is the change in momentum? Again, you have the given values: mass, initial velocity and final velocity. The formula to calculate change in momentum is mv minus mu. Now m is common in that, so taking m into v minus u, substitute the values and you get the answer as 3.2 into 6.5 meter per second, that is 20.8 kilogram meter per second. So isn't this problem also easy for you? Now let's move on to the next problem. A football of mass 200 gram moves with a velocity of 30 meter per second. A bullet of mass 10 gram is projected with a velocity of 250 meter per second. On the other hand, a tennis ball of mass 50 gram moves with a velocity of 36 meter per second. Which of these have maximum momentum and which one has minimum momentum? Yes, in order to understand that, we have to calculate the momentum of each of these objects. Now what is the formula for momentum? Momentum is mass into velocity. So momentum of the football will be mass of the football into velocity of the football. Substitute the value. Mass here is 200 gram. Since the unit of momentum is kilogram meter per second, we have to express the mass of the football in terms of kilogram. So 200 gram will be 0.2 kilogram into 30 meter per second. Calculating, you get the answer 6 kilogram meter per second. Similarly, calculate the momentum of the bullet and momentum of the tennis ball. So momentum of the bullet will be mass of the bullet into velocity of the bullet, and momentum of the tennis ball will be mass of the tennis ball into velocity of the tennis ball. So find out and check whether your answer is correct. Now compare the momentum of football, bullet and tennis ball. Which is having the maximum momentum? Yes, football is having the maximum momentum. And which one is having the minimum momentum? Tennis ball. So I hope that you have understood the concept of momentum, its examples in everyday life and how to calculate momentum. Always remember that only moving objects have momentum. Resting objects have zero momentum in them. If you like the video, press the like button, share the video and subscribe the channel.